So if you want to generate some report, so after click solve, let's select all the reports that we want to collect. So we have the reports. We'll talk about the reports later. Okay, so one of the report that we want to talk about right now is the answer report. Here we have the actual values for different processes, and for example, the first process, if we want to reach the optimal solution, we need to consume 30 hours, which is called binding. So what is a binding constraint? A binding constraint is the one that holds an equality as the optimal solution. So in this case, so the constraint is, for this process totally we have 30 hours, and as the optimal solution we have to use up all the hours. So that's binding solution. And the third one is also a binding constraint. I apologize, it should be binding constraint. And the second and fourth one are not binding. We didn't use up all the hours. So the slack means slack value is the number of hours that are not used. So if we go back and if we add a non-negative slack variable, so that the value of that variable will represent the slack value. So that problem was a maximization problem. We wanted to maximize the profit or maximize the objective function. The next one is to study the minimization problem. So in this type of problem, we want to minimize our objective function value. So here we have one example. So M&D Chemicals, so that's a company who produce two products. One is A, the other is B. So we have some requirements. So for the combined production for both products, we have to produce at least 350 gallons. But we have one more additional requirement for product A. Because of an order from a major customer, we have to produce at least 125 gallons of product A. So for the production side, we have to spend 2 hours to produce each gallon of product A and 1 hour for each gallon of product B. And totally we have 600 hours for our production. And the production cost $2 per gallon for product A, $3 per gallon for product B, and our objective is to minimize our total production cost and meet our demand or our requirements that we discussed in the previous slide. Now let's formulate our problem. So let's define our design variables. So let's use A to denote the number of gallons for product A, and B for the number of gallons of product B. So our objective is to minimize 2 times number of gallons of product A plus 3 times the number of gallons of product B. Then we have some constraints for product A. The production quantity has to be at least 125. So for the total production, it has to be at least 350. And for the processing time, it cannot be over 600. And of course, our decision variables have to be non-negative. So the next job is to solve the, let me close this one. Let's solve the problem. Okay. So we have all the data here. So processing time, production cost, objective function, our decision variables, our constraints. Then let's solve the model solver. So objective function is, this is our objective function, and we wanna minimize. We're gonna minimize our objective. And by changing variable cells, so we need to select our decision variable, B14 and C14, and then we need to define our constraints. So the first set of constraints is to make sure the production quantities are within our constraints, and the second one is to make sure that our number of hours used is not going to be over 600. Then let's select the simplex linear programming method. Solve. Let's select all the reports, and okay. So we have all the reports. So the optimal solution is 250 for product A and 100 gallons for product B. And then if we look at the result or the report, we can see there's something called surplus variable. So if we go back, answer report, so here, so we see here the second and the third constraints are binding constraints, but for the first one, product provided the value for the optimal condition is 250, but the constraint on the right hand side is 125. So we produced more product A compared to the least amount of from the requirement. So that's called surplus value. So it tells us how much over the right hand side, the difference between the right hand side and left hand side. So that's a surplus. So surplus value. Okay. So that's all we have. So we have the screenshots. So that's our report. So the same thing as we have in the Excel. So then the next topic is to discuss some special cases. So in the previous two examples, we had unique optimal solutions for each of the problem, but in some cases, we may have more than one optimal solutions. So an alternative optimal solution is one where optimal objective functions contour line coincidence with one of the binding constraint lines, which means we have multiple optimal solutions. Okay. So let's go back to the first example. So we want to maximize our profits by deciding how many basic or standard bags to produce and how many deluxe bags we need to produce. So this is the original objective function. What if we change the objective function to this one? So we solve the problem, and then we still analyze this figure, and we find out, okay, so extreme point 3 and 4 both give the best solutions, or both give the maximum profit, and all the points on this line will give the same objective function values. So we have multiple solutions here. So that's so that means we have multiple alternative optimal solutions.